All right, so I'm sure as you guys know, radioactive materials are generally considered as not safe. So let's take a look at the effects on biological systems. There are a lot of medical uses of nuclear chemistry, but if you want to take a look at that, go ahead and do that on your own. So effects on the biological system when we're talking about nuclear reactions, what they do essentially is they damage the DNA of our cells. And remember, the DNA of our cells is what tells our cells what to do. And so when you damage this DNA, you increase your chance of cancer. Cancer is kind of unmitigated cell replication. The cell just keeps multiplying again and again and again, and you develop a tumor. And the way it damages DNA is through ionization, either direct or indirect. So here's a little picture of this. You have some kind of radiation source, it damages the DNA, and then the DNA causes a cancer cell, so a cell that keeps replicating beyond what it's supposed to, and then it keeps replicating and replicating and replicating, and then you have a cancer or a tumor. And so there's two types of radiation when we're talking about electromagnetic radiation. First off, there's the non-ionizing radiation. And so this is light spectra that don't have enough energy to make ions. So they cannot make ions. So this is something like your cell phone towers, your radio waves, 5G that's coming out. So you'll hear, oh, maybe your cell phone's giving you cancer. No, that's all just a bunch of baloney. This type of radiation is not nearly powerful enough to ionize things and thus cause cancer. But there'll always be people trying to, convince you otherwise. If you're paying attention to the news, the new thing is there's idiots saying that 5G is causing, the coronavirus. So, yeah, what are you going to do? The second type is ionizing radiation. So ionizing radiation is higher energy, and so it can ionize. And so this is the one that you have to be careful of, because this is the one that will ionize your DNA and thus cause, health issues. And so if you take a look at the light spectra, you can see here, this green arrow, everything around here is ionizing, and then everything to the left is non-ionizing. So you can tell it's higher energy light is more ionizing. So you can tell the gamma rays from our nuclear reactions, that's ionizing. X-rays, that's why you have to have that kind of lead vest when you get your X-ray taken. And then ultraviolet rays, right, coming from the sun, that's where you have to wear sunscreen, and if you don't get a sunburn, and then eventually, skin cancer. But then we can see the rest of the types of light are non-ionizing. So, your visible light, it's not going to hurt you. Your infrared light, it's not going to hurt you. The kind of cool one here is microwaves. A lot of people think microwaves are very high energy, but they're actually not that high energy. So there's two kinds of things that you have to think about in terms of the ionization power or effect of ionization or danger of ionization. And that's the ionization power versus its penetration ability. So some things are able to ionize very strongly, but they can't penetrate, so it's not that big of a deal. And so really it's kind of penetration that ends up being the more important one. So let's take a look at that. We already discussed this a little bit. So we have our alpha particle here, and remember we said that one was the most ionizing. And so you'd think it might be the most dangerous, but it's actually not all that dangerous, and that's because it's not very penetrating. It can't break through a piece of paper. It can't go through your hand at all, and so this, would be kind of just deflected by your skin. It might kill that skin cell, but it won't really damage that DNA, and so it's not really too big of a concern, assuming you don't eat it. And then on the bottom, we kind of have gamma rays, and even though they're the least ionizing, they're kind of one of the most concerning, because as you can see here, they'll go straight through all of this stuff. Eventually, I think it's stopped by lead. And so this stuff will go through your cell and thus can interact with your DNA and thus cause cancer. Cool, that's it.